Around 66 million years ago, a well-known dinosaur named Tyrannosaurus rex roamed North America. It was the most fearsome and most powerful carnivore to ever exist, but this didn't just happen by itself. If we go 10 to 15 million years further back in history, another Tyrannosaurid theropod dinosaur started evolving, the Gorgosaurus. This dinosaur had features and behaviors that made it an apex predator in its environment, and it played a huge role in the later development of Tyrannosaurus rex. But to fully understand its adaptations and features, we have to take a closer look at the evolutionary arms race that shaped one of Earth's most successful predator lineages. Early Tyrannosaurids were far from the big dinosaurs we imagine when we think of T-Rex. These creatures sported slender builds, long legs, and lightweight frames, almost more gazelle than grizzly. These adaptations made them perfectly suited for chasing down smaller prey while avoiding larger carnivores that dominated their world. But the prehistoric world was changing, and so did the pressures that shaped Tyrannosaurid evolution. Other predators grew larger and more formidable, forcing Tyrannosaurids to adapt or face extinction. The evolutionary arms race was on, and it would transform these swift hunters into some of the most fearsome creatures to ever walk the earth. Over millions of years, Tyrannosaurids underwent a remarkable metamorphosis. Their bodies became more robust, trading some agility for raw power. Their jaws evolved to deliver bone-crushing bites, perfect for taking down larger prey. Their senses sharpened dramatically, turning Tyrannosaurids into hunters capable of tracking and ambushing prey with deadly efficiency. By the time Gorgosaurus appeared around 80 million years ago, Tyrannosaurids had reached truly impressive proportions. But by growing up to 30 feet or 9 meters long and weighing 2 to 3 tons, Gorgosaurus had become a dominant predator by that time. The arctometatarsus, a unique foot bone adaptation, allowed for greater agility and running efficiency. This made it possible for Gorgosaurus to reach speeds of 25 to 30 miles per hour or 40 to 48 kilometers per hour, which is impressive for an animal of its size and very different from what the Tyrannosaurus rex managed to reach. These features and adaptations played a big part of dominating the ecological niche Gorgosaurus occupied, allowing it to outcompete other predators for food. As some fossil evidence suggests, it preferred to hunt large hadrosaurs, which there were plenty of in its environment. This reflects its status as an apex predator and might be some of the reasons for its success over millions of years. So if you think that sounded amazing, please give this video a like and a subscribe to the channel if you want more content like this in your feed. While Tyrannosaurids as a group were formidable, Gorgosaurus evolved some adaptations and abilities that took it to a whole new level. Its speed, bite force, and visual abilities were all some features that made it stand out as an apex predator of its environment. But what was actually so different from the other Tyrannosaurids that gave Gorgosaurus an edge over them? The answer lies in some highly specialized adaptations together with its physical abilities. Its skull, measuring around 2.9 to 3.2 feet or 90 centimeters to 1 meter long on average in adults, was deep and broad, and built to withstand incredible biting forces. This robust design allowed Gorgosaurus to unleash devastating attacks on its prey without risking self-injury. Some scientists suggest, based on research, that Gorgosaurus could deliver bites at a force of 5,000 to 7,800 psi. This will highly depend on which stage of growth it was in. Whether these numbers are 100% scientifically correct is still being debated in some scientific communities, but they all agree that it gives an impression of what forces Gorgosaurus were capable of creating. But a highly specialized skull wasn't the only adaptation that made Gorgosaurus stand out. It also possessed a dental arrangement that was quite outstanding at the time. Overall, an adult specimen would have around 34 to 38 teeth with an average length of 5 inches or 15 centimeters. Some specimens have been found with teeth at a length of 7 inches or 18 centimeters, but most paleontologists seem to agree on this being exceptional specimens. What they otherwise did have in common was that these teeth were serrated like steak knives, perfectly designed for puncturing, gripping, and slicing through flesh with a high amount of force. But to truly be an apex predator, a deadly bite wasn't enough. With such big developments of its head, both in size and abilities, evolution had to make some changes to its body structure as well. To counterweight its massive head and torso, it developed a long and heavy tail. This made it possible for Gorgosaurus to stay agile and balanced during high-speed pursuits. Like many other Tyrannosaurids, it also had 2 small arms, which included 2 small and weak claws. They would probably only have been used to stabilize prey because of their size and weakness. Another thing that made Gorgosaurus different from other Tyrannosaurids was a unique ridge crest above its eyes. While we can't know for sure, paleontologists think this feature played a crucial role in species recognition, communication, or even as a display feature to attract males or intimidate rivals. All of these adaptations indicate that Gorgosaurus was well adapted to reign supreme as an apex predator of its ecosystem. But being an apex predator didn't mean that Gorgosaurus lived an easy life without challenges. Every day was a high-stakes game of survival, and sometimes the greatest threat came from its own kind, other Gorgosaurus. In a Cretaceous ecosystem teeming with life, Gorgosaurus was dependent on its keen senses to gain an overview of potential prey and threats. Its ecosystem included an abundant amount of herbivorous dinosaurs, like ceratopsids and hadrosaurs, and they were the preferred prey of an adult Gorgosaurus. But even having an abundant amount of prey, catching them wasn't that easy for all types of dinosaurs. Therefore, it was important for Gorgosaurus that it had developed some unusual physical characteristics compared to other Tyrannosaurids. With its lightweight body structure and long, powerful legs, it was one of the most agile predators of its time. This gave it a big advantage and made it possible to cover vast territories in search of food. But to be guaranteed a successful hunt, speed and agility wasn't enough alone. Therefore, research suggests that it developed a superior intelligence, which made it possible for Gorgosaurus to plan and execute complex hunting strategies. This resulted in a hunt that often targeted weaker or isolated individuals within a herd. But life wasn't just challenging for adult Gorgosaurus. Juveniles faced their own types of challenges for survival. Discoveries within paleontology have shed light on some fascinating dietary shifts as these predators grew. A juvenile Gorgosaurus fossil was found with stomach contents that included the remains of a small oviraptorid, providing direct evidence of their hunting habits. This suggested that young Gorgosaurus targeted smaller, faster prey like juvenile oviraptorids, avoiding direct competition with not only other Tyrannosaurids, but also other larger adults of its own kind. Adult Gorgosaurus faced some challenges as well. Even with its adaptations for its place as an apex predator, success was far from guaranteed. Other Tyrannosaurids were on the hunt for the same prey, which made the hunt dangerous and could, in the worst case, result in death. But there was one thing that was even worse than other Tyrannosaurid species, and that was cannibalism. Evidence from the fossil record indicates that Gorgosaurus frequently engaged in intraspecific competition, with adult specimens showing bite marks attributed to other Gorgosaurus individuals. This tells us that Gorgosaurus led a life filled with physical confrontations. These confrontations were most likely over prey, territory, or mates. The fossil record reveals a high degree of resilience in these creatures, with several specimens exhibiting healed injuries from fights. All of those battle scars paint a picture of the world they inhabited and their incredible ability to adapt. But some research suggests a topic that sounds far off when we hear about all of these intraspecific confrontations. It suggests that Gorgosaurus may not have been purely a solitary hunter. Some evidence points to the possibility of some level of social behavior, potentially including hunting in groups or family units. While this aspect of Gorgosaurus behavior remains a topic of ongoing research, it adds another layer to our understanding of these creatures. But why might such social behavior have evolved in these fearsome predators? While most people think about apex predators being solitary hunters, fossil findings show us a possibility of these dinosaurs living in groups. Adult Gorgosaurus individuals preserved together and also juveniles preserved together with other adults points to the existence of family units or pack hunting dynamics. This arrangement could have provided significant advantages in both hunting and protection, allowing them to take down larger prey and defend themselves against other predators. Cooperating like this might be a potential explanation on why they dominated their ecological niche like they did. To be able to live in social groups like this, Gorgosaurus had to evolve something that made them recognizable for each other. Here's where the distinctive eye ridge crest I mentioned earlier comes into play. Scientists have a theory about this feature being used for social signaling and mate selection, similar to the elaborate displays we see in modern birds. This visual communication might have helped establish hierarchies within groups as well. The implications of these social behaviors are profound. By working together, Gorgosaurus likely gained significant advantages over solitary predators. In modern ecosystems, we see how social structures enhance hunting efficiency and survival among apex predators like lions and killer whales. These same benefits could have applied to Gorgosaurus, allowing them to dominate their prehistoric world. This newfound understanding of Gorgosaurus' social behavior provides valuable insights into the complex dynamics of prehistoric ecosystems and the factors that contributed to their dominance for millions of years. But how did this make it possible to coexist in an environment that included many other types of predators? The answer lies in a prime example of niche differentiation in action. Gorgosaurus got its biggest competition from a dinosaur named Daspletosaurus. These two dinosaurs were quite a similar size, but they evolved distinct adaptations and behaviors that made it possible to coexist without constant conflict. A key role in their coexistence was the geographical preferences. Gorgosaurus fossils are more common in northern areas like Dinosaur Park, while Daspletosaurus remains are typically found in southern regions. This subtle separation reduced direct competition for resources and territory. But sometimes their ranges overlapped, and even when it did, these Tyrannosaurids specialized in different prey. Gorgosaurus likely focused on swift targets like hadrosaurs, while Daspletosaurus may have hunted heavier, armored herbivores such as ceratopsians and ankylosaurs. This prey specialization allowed them to exploit different resources within the same ecosystem. Their physical differences further reinforce their distinct hunting strategies. Gorgosaurus evolved a lighter build for speed and agility that allowed for quick pursuit of prey. In contrast, Daspletosaurus developed a more robust, power-oriented physique. These adaptations reduced direct competition and made it possible for them to fill different ecological roles. This also helped to create a clear distinction between the two predators. Interestingly, Gorgosaurus specimens outnumber Daspletosaurus by 2-to-1 in the fossil records from the Dinosaur Park formation. This ratio suggests that Gorgosaurus may have been more prevalent in certain areas and might have outcompeted Daspletosaurus through sheer numbers. The coexistence of Gorgosaurus and Daspletosaurus demonstrates how large predators can adapt to share resources within the same ecosystem. However, their reign wouldn't last forever. As the Cretaceous progressed, new challenges emerged. Changes in climate, changes of prey populations, and the rise of new competitors would test the adaptability of these Tyrannosaurids. It was time for a new chapter in their evolutionary story, a chapter that would lead to one of the most iconic Tyrannosaurid species in Earth's history. But how did the evolution of Gorgosaurus play a part in this further development? Gorgosaurus represents a critical stage of Tyrannosaurid evolution. This stage of evolution paved the way for even more formidable hunters. Being classified within the Albertosaurinae subfamily of Tyrannosauridae, Gorgosaurus worked as a stepping stone in the transition from swift, agile forms to the more robust powerhouses that would dominate the latest parts of the late Cretaceous. Its robust skull and powerful jaws foreshadowed the extreme adaptations of later species. These traits were refined and amplified in subsequent Tyrannosaurids, culminating in Tyrannosaurus rex, which pushed terrestrial predator size and power to their limits. Another thing that played a big part for the evolution was the discoveries of different Gorgosaurus specimens preserved together. This might be evidence for a trait that could have laid the foundations for even more complex social structures in later Tyrannosaurids. The success of Gorgosaurus and its relatives likely contributed to the extinction of other large predators. This paved the way for further evolution and played a big part in the Tyrannosaurid dominance in the later years as well. As these formidable dinosaurs kept on evolving, they slowly evolved into a new dinosaur species within the Tyrannosauridae. This dinosaur species would keep on maintaining its position as an apex predator until the end of the dinosaurs. Today it's considered the most dangerous and feared carnivorous land animal that has ever roamed the earth. And as you might have guessed by now, that was the Tyrannosaurus rex. If you want to learn more about that fearsome predator, check out this video. Thanks for watching, and until next time.